Let us study about an important property or phenomenon called as polarization. To define this, we can say it is a phenomenon in which the vibrations of electric vector are made to occur in only one plane. To make sense out of this, let us consider an electromagnetic wave. An electromagnetic wave consists of two kinds of fields called as magnetic field and electric field. These two are basically oscillations or vibrations. These two fields are perpendicular to each other, and these two fields are in turn perpendicular to the direction of propagation of wave. As seen in this diagram, the wave is propagating along the x-axis, while the magnetic field or the magnetic vibrations are confined to the y direction. And here, the electric field vibrations are confined to y directions as shown here by the yellow color vibrations, and the magnetic field vibrations are confined to the z directions. Whenever we talk about light or optical properties, we are talking only about electric field properties. So in this case, the electric vibrations are perpendicular to the direction of propagation of the wave. Now what happens is, when we look at an atom, if an atom is de-excited, that would give out a photon, and that photon is like a wave train, and that contains some electric field vibrations. An atom may emit around 10 power 8 wave trains per second. That is, it may emit 10 power 8 photons per second. Now each of this wave train will have a given electric field vibrations. That is, in one case of a one wave train, electric field may be confined in this direction. For another wave train, it may be in this direction. Another, it may be in this direction. So it keeps on emitting wave trains in which electric field vibrations are in different plane. But for every wave train, the electric field is always perpendicular to the magnetic field. But here we are restricting the discussion only to electric field vibrations and not the magnetic field. But always in every wave train, the magnetic field is also perpendicular to the electric field vibrations. Now a human eye cannot catch or cannot differentiate this many number of wave trains. So what a person would see from a source of light is that this wave trains which are reaching the person will contain electric field vibration in all directions. So this kind of a light is said to be unpolarized light because it contains all the possible electric field vibrations and planes. Now suppose if the electric field vector is restricted to only one plane, if we remove every other plane and if we restrict it to only one plane, that phenomenon is called as polarization. So to recap it, we can say it is a phenomenon in which the electric field vibrations are made to occur on only one plane. An important property here is it is shown only by transverse wave. That is because both transverse wave as well as transverse waves as well as longitudinal waves exhibit certain properties. The properties like interference and diffraction is shown by both kinds of the waves. But there is one property which differentiates these two kind of waves, and that property is called as polarization. So we can say that this is a property which differentiates or transfers wave from a longitudinal waves. To understand this, let us consider, for example, like a string on which certain vibrations are set. For example, think of a wave on a string like this. Now suppose if we have opening like this, through this, say, some kind of arrangement, then what happens here is this wave will come out like this. It will pass through the opening. But instead of keeping it like this, suppose here only, if we keep the opening in such a way that the opening is kept in this plane, it's kept like this, then nothing will come out of this opening. But if you look at, say, sound wave, if sound wave is passing through an opening, it doesn't matter how the opening is, because it's just vibrations. Whether opening is like this or opening is like this, the sound will pass through it, which means polarization is a phenomenon which is shown only by transverse wave. So as seen here, we have electromagnetic wave which contains all the possible vibrations. We put an arrangement, a device, or a crystal called as polarizer. This crystal will limit or restrict the vibrations to only one plane. So as seen here, what we get out of this is the electric field which are confined to only one plane. So this is called as a polarized light.